Hello everyone, welcome back to my YouTube channel. So in this video, let us discuss about analysis of unbalanced three-phase delta connected load. Important, they may ask in examination from module FI8, so that you just have to know because it is very important. So analysis of unbalanced three-phase delta connected load. For this, you need to consider a delta connected load first. It is having R, Y, B, and in between R to Y, Y to B, B to R. Delta connected load is nothing but one end of phase is connected to the starting phase of another end of the phase. Okay, so that you can see R to Y, Y to B, B to R. Okay, and it is having unbalanced load. Unbalanced means the load between R to Y is ZRY, and the load between Y to B is ZYB, impedance load. Load between B to R is ZBR. All the three loads are different values, not same. And from R to R, IR, line current is flowing, line current is flowing, line current is flowing, and it is divided at R, and the line current is divided and it is splitting in terms of phase current. So the phase current from R to Y, whatever it is flowing, that is IRY, Y to B is IYB, B to R is IBR. So that you should define line currents and phase currents here first. That is why I am defining here the phase currents are current flows to the phases. R to Y phase is IRY, Y to B phase is IYB, B to R phase is IBR. Similarly, you can see the line voltages also. The voltage between R to Y line, Y to B line, similarly B to R line, that is VBR. The condition of delta connected load is line voltage is the same as phase voltage, but line current is root 3 times of phase current. That's why phase current you're writing IRY, IYB, IBR. These three are having a different values because the supply may be unbalanced sometimes. So how we are writing IRY now? Just simple. You know that V equals to I into Z. IRY like this. IRY is given by VRY divided by ZRY. Similarly, IYB is VYB divided by ZYB. IBR is nothing but VBR divided by ZBR. Phase currents. You need to calculate the phase currents with help of this. Line currents. To find the value of line currents, you can see the line currents now. What are the line currents? IR, IY, IB. These are the line currents. To find the line currents, you need to apply KCL at every junction. Then you'll get to know the values of line currents. For example, so now we can see the line currents. IR is a line current. It is flowing towards R and it divides it as IRY and IBR. IRY is leaving from R, IBR is entering to R. So that you just apply KCL at R. What KCL says? Algebraic sum of current leaving from the junction is same as flowing towards the junction. So which current is flowing towards the junction? IR is flowing towards the junction R. IBR is flowing towards the junction R. But IRY is leaving from the junction, so that the algebraic sum of current leaving from the junction is same as current entering to the junction. That is IR plus IBR is current entering to the junction is same as leaving the junction is IRY. So with the help of this, you are getting IR, that is line current is given by IRY minus IBR. You can see the line currents. KCL at node R, incoming current same as outgoing currents. Similarly, with apply at Y and B, you'll get these current values. Then you need to find power, real power, reactive power, apparent power. So impedance loads will be having ZRY is nothing but RRY plus J into XRY. Either it is plus J or minus J. If it is a plus J, it is inductive load. If it is a minus J, capacitive load. If there is no J, resistive load. Similarly, how we are writing ZYB? ZYB you write it as RYB plus J into X, Y, B. Similarly, ZBR, RBR plus J into XBR. Real power means you need to consider real values. So that power is given by I square into R. So that real power is given by I RY square. Three phases are there, three phase currents are flowing. So that I RY square into RRY plus IYB square into RYB plus IBR square into RBR. Whereas RRY, RYB, RBR are the real parts of the load. Similarly, you do it for the for reactive power. What you're doing? I square into X. Reactive means complex value of load impedances. Then apparent power means square root of PT square plus QT square. So this is the analysis of three-phase delta connected load. So if you're having any doubts regarding this, feel free to write in the comment box. If you really like this video, please do subscribe and share maximum. Thank you so much. Have a nice day.